We are characteristic study on A356 aluminum alloy coated with nickel and silicon carbide. Of late, aluminum and its alloys have attracted widespread attention. Why is it so? It is because of its low density, high specific strength, corrosion resistance, high electrical and thermal conductivity. But due to its versatile nature, aluminum is being touted as the best material to replace steel in weight-saving applications. But there is a problem. In tribological applications, aluminum has a very low wear resistance. To solve this problem, we coated the aluminum alloys with Nicasol coating. Nicasol is a coating which comprises of silicon carbide particles dispersed in the matrix of nickel. This increased the wear resistance of the aluminum alloy. The materials used in this experiment were the uncoated aluminum alloy, the Nicasol coated aluminum alloy, and the conventional cast iron Fg250. The chemical composition of all the three samples were calculated using the optical emission spectroscopy. All the three samples were subjected to the reciprocating VR test. In this test, there is a pin and a cylinder sleeve sample. The pin is slid against the cylinder in a linear reciprocating manner. So due to this reciprocating motion, it results in the wear of the cylinder and the pin. The pin used in this test was cast iron Fg250. The same pin was used against three different samples. So that is indicated here. Sliding couple A is cast iron versus cast iron. B is aluminum uncoated A332 case versus cast iron. And C is the Nicasol coated aluminum against cast iron. So this test was conducted for a period of 30 minutes for a stroke length of 2 mm and a frequency of 50 Hz and a load of 55 Newton was applied for all the three samples. From the results of the reciprocating wear test, the values of coefficient of friction are plotted against time. These are the values of the coefficient of friction, and it is seen that Nicasol shows the lowest coefficient of friction. The sample B, sliding couple B, shows the highest coefficient of friction. In the wear mass data loss, the mass loss in A332 uncoated alloy is more. The Nicasol coated sample shows the least mass loss. This shows that only negligible wear or minimum wear has occurred in the sample. All the three samples were subjected to Vickers micro hardness test, and as expected, the Nicasol coated aluminum alloy showed the highest hardness. This is due to the hardness of the Nicasol coating. All the three samples were subjected to light microscopy studies and scanning electron microscopy studies after being subjected to the wear test. In this cast iron sample, we can see that adhesive wear has taken place. This is due to the fact that materials of the same chemical composition, when slid together, produces adhesive wear more likely. In the uncoated aluminum sample, we can see that abrasive wear has occurred. This is because the cast iron pin, which is the harder material, has slid against the uncoated aluminum, which is the softer material. So, there is ploughing seen on the SEM images, agglomeration, and the wear debris has settled to the side of the wear track during the wear test. All these have contributed to the high coefficient of friction and the mass loss which was seen in the previous slide. In the Nicasol coated aluminum sample, only mild abrasive wear was reported, and this confirms the low coefficient of friction and the low mass loss which has occurred during the test. So our Newcastle coating has performed very well during the reciprocating VR test. So on conclusion, we say that the Newcastle coated aluminum sample is an efficient competitor to replace the conventional cast iron in many automotive and aerospace applications, owing to its high hardness and superior VR resistance. Thank you.